Hello, my name is Scott Minnick, and I'm a meteorologist with the National Weather Service in Wakefield, Virginia. This presentation was put together for the purpose of sharing a winter outlook for the Wakefield forecast area. The forecast area includes central and eastern Virginia, as well as northeast North Carolina and the Maryland Eastern Shore. Hopefully this outlook will help you be better prepared for the upcoming winter. A special thanks to Larry Brown and Jeff Orrock for their help with this presentation. The first thing we'll look at is the ever-important and well-advertised El Niño Southern Oscillation, or ENSO, phase. The reason ENSO gets so much press is that it is a big driver in winter weather. Niño 3.4 represents the section of the Pacific Ocean that we look at sea surface temperature anomalies to determine El Niño versus La Niña. Quickly, El Niño is represented by a 3-month average of sea surface temperature anomalies greater than 0.5 degrees Celsius. La Niña is represented by a 3-month average sea surface temperature anomaly less than negative 0.5 degrees Celsius. The range from negative 0.5 to 0.5 degrees Celsius is called ENSO neutral. For more specific information on ENSO, please navigate to the link at the bottom of the slide. The latest observations depicted in the upper left image depicts the Niño 3.4 region right around 0.5 degrees Celsius. The latest model guidance in the lower left image, provided by the International Research Institute for Climate and Society, shows models clustered in the 0.5 to 1.0 degrees Celsius range. This has led to increased confidence that El Niño will in fact develop in the coming months. The bar graph on the right depicts the plume model graph in probabilities. El Niño is now favored with a probability of 70 to 80% through the winter months and into spring. The latest ENSO discussion from the Climate Prediction Center states that there is an approximately 65% chance that El Niño conditions will be present during Northern Hemisphere winter and last into Northern Hemisphere spring 2015. So what impact does El Niño have on the U.S. and more specifically the Wakefield forecast area? Well, let's have a look. The El Niño pattern is provided in the image above. El Niño episodes feature a strong jet stream and storm track across the southern part of the U.S. and less storminess and milder than average conditions across the north. The increase in flow of marine air into the southern U.S. results in cooler and wetter conditions than normal. This is also true for the local area. Typically during El Niño episodes, the mid-Atlantic region is cooler and wetter than normal. With the El Niño pattern in mind, the Climate Prediction Center depicted higher probabilities for below normal temperatures across much of the south, extending into portions of the mid-Atlantic region. CPC also predicts above normal precip across the southern U.S. and up the eastern seaboard. You can see that in the right image. Drier conditions are expected across the Northwest and Great Lakes regions. Also displayed are select cities' average precipitation and snowfall amounts. Richmond and Norfolk receive right around 21% of their annual precip during the winter season. While we have the luxury of a strong climate driver this winter, research has shown that short-term climate patterns can still have a major impact on the local area regardless of the ENSO phase. However, these climate indicators are highly variable and difficult to predict outside of a week or two. ENSO can point to a general overview of the entire winter, but the presence of a strong short-term climate pattern can turn the winter prediction upside down for a period. So what are these short-term climate drivers? Remember how cold November was? A top 10 coldest for Norfolk, in fact. All thanks to the Arctic Oscillation. The Arctic Oscillation is an atmospheric circulation pattern in which the pressure over the polar region varies in opposition with that over the middle latitudes. When the pressure is low in the Arctic and high in the mid-latitudes, the Arctic Oscillation is in its positive phase. This is the image on the left. When the pressure is high over the Arctic and low in the mid-latitudes, the AO is in its negative phase, and that is the image on the right. A strongly negative phase of the Arctic Oscillation brings warm weather to high latitudes and cold, stormy weather to the more temperate regions where people live. This is exactly what happened in November. The AO dipped negative during the middle of the month, resulting in well below normal temperatures for a period. The result was the 21st coldest November on record for Richmond and the 6th coldest on record for Norfolk. The forecast is also depicted through mid-December, with a mean staying right around an index of 0. The AO is much like the North Atlantic oscillation pattern that we talked about last winter. One of the most prominent teleconnection patterns in all seasons is the North Atlantic Oscillation. The NAO combines parts of the East and West Atlantic Ocean patterns for the winter season. The positive phase of the NAO reflects below normal heights across the high latitudes of the North Atlantic and above normal heights and pressure over the central North Atlantic, the eastern United States, and western Europe. The negative phase reflects an opposite pattern of height anomalies over these regions. Both phases of the NAO affect the location and intensity of the jet stream and the resultant storm track. Strong positive phases of the NAO tend to be associated with above average temperatures in the eastern United States. The NAO is highly variable during the winter season due to the drastic differences in temperatures between the poles and mid-latitudes. It is very difficult to forecast outside of 1 to 2 weeks. Observations are shown in the bottom image, as well as the forecast through mid-December in red. The Arctic Oscillation and the North Atlantic Oscillation patterns are quite similar. But enough with science. How about the important forecast, snow? Taking a look at ENSO and the NAO versus snowfall at Richmond since 1950, we can see some correlations. The above graph depicts snowfall days versus ENSO and NAO phases. First, all cases, ENSO and NAO, average 7 measurable snow days and a total of 12.7 inches during the season. El Niño cases do not deviate much from the normal, while La Niña tends to be slightly lower on measurable snow days, but about 4 inches lower on snow accumulations. A positive NAO phase, regardless of the ENSO phase, is associated with the least amount of average snowfall, but still includes 5 measurable snow days. The most favorable phase for more snowfall is a negative NAO. The average snowfall from negative NAO dominated winters is 19.1 inches with 9 days of measurable snowfall, which is by far the greatest winter for snowfall. ENSO neutral, which we experienced last year, also tends to be snowier than normal, coming in at 14.2 inches with 8 days of measurable snowfall. With El Niño developing, there appears to be a higher probability for slightly above normal snowfall. If a negative NAO develops, then there is even a higher chance of receiving above normal snowfall. However, if a positive NAO develops, it will likely limit the amount of snowfall in the area. In summary, El Niño is forecast to develop this winter into spring 2015. El Niño and the Climate Prediction Center favor increased probabilities for below normal temperatures and above normal precipitation for the Wakefield forecast area. El Niño also favors slightly more snow than normal, which can be enhanced or limited by the phase of the North Atlantic Oscillation. And with that, we'll wrap up this winter presentation. Thank you for viewing, and if you have any questions or comments, please feel free to get in touch with any of the people listed. I have also included some important links for anyone to follow the latest weather and climate information. Thanks again, and be safe.